Hi. So I guess it's time for me to show you what I've been working on. So I've been working on what you have on screen right now, an optical design platform assisted by AI. And what I mean by that is that you don't actually have to kind of learn how the software works or to go through any documentation to do optical design. The AI knows it. So basically, you tell what you want to do, what you need to do, and of course, you still need some engineering skills to do in what direction to go and to set the goals. But when it comes to preparing the work, setting up all the parameters and stuff like that, the AI can actually do it for you. So it's faster, and you don't have to go through a lot of documentation to learn how to use it. So let's have a look at an example. I'm sure many of you have seen the tutorial from ANSYS with the James Webb Space Telescope. So basically, we will try to redo it here in this interface. And to do so, we first need to load the setup, right? So load an optical setup, uh, the James Webb Space Telescope. Actually, it would have been very nice, and that will be for another video, to show that the AI can create the setup for you if you provide the right information, whether it's a link, whether it's a picture, whether it's a PDF. In that case, because it's a short video focused on overall specifications, we will fetch it from the database. So first we load the optical setup, then we do a spot diagram analysis, then we optimize the image plane. Yeah, and then another spot diagram analysis to see the results, right, of the optimization. And as you see, I don't actually have to load, look into any menu. I just tell the AI what I want to do, and the AI has access to all these tools for me. So it will basically create the workflow based on my prompts and my specifications and ask me to review. And it's what we have here. And everything seems perfect. So let's confirm and load. And a few seconds a few seconds later, we actually, yeah, have the right setup. We can review it more in details here if we want all the fields and stuff. Because it's from the database, I know it's okay. In another video, I will show you how that works when you generate a setup with the AI from scratch. Here, I just want to maybe change slightly the parameters to see all the fields with more rays. And all right, this is actually the core of what we'll be doing, the optimization of the image plane. And as we can see, it has been mostly prepared okay. I just want to use another method. So yeah, I will use this method for the optimizations because it's just more accurate. I also don't want to optimize for all fields. I just want to show a crazy improvement. So we'll optimize for the main fields. And yeah, this parameter seems about right. And we'll have 50 iterations. That should be enough to see like already some improvements. And finally, the spot diagram after optimization. So yeah, the right parameters are here. And let's run the workflow. So what's happening behind the scene right now is just simple, plain optical optimization. It's using basically conventional methods. There is no AI whatsoever involved at this stage because we are not using also any tools based on AI. The AI was here to create the workflow, to reduce our workload, to help us go faster, but it's not used right now. It could be, but that will be another video. And it seems that, yeah, it works perfectly fine. So on the left, we have the spot diagram before optimization, then the optimization with basically what has been changed, the position. So we have a slight decenter. It's normal because the main field is actually off-axis 40 setup. We have some tilts, which is also seems like very well in what we expected. And same for other parameters. So the radius has been changed. It's also what we expected for this setup. And we can see that the final result is actually quite amazing for the main fields. And because we optimize for the main fields, we don't expect the other ones to be as good, but that's fine for the demo. All right. And here the setup has been loaded, so we can have a look at it. We can go back and see what have been changed here. So typically we see that the radius has been updated and the image plane has been slightly tilted and decentered. But what would be nice to see uh, is actually the ray tracing. So let's look at that. We have a tool for that, luckily, and removing the parameters, everything, it's okay. So let's run it. And once again, here no AI whatsoever. It's just a real ray tracing with very conventional algorithm. And here we can see the results. So one color per field. Oops. Yeah. All right. So one color per field. And we can have a look at the result in 3D, but also in 2D. Yeah. Some of you may notice that some of the rays are going through this mirror here. Once again, it's because it's a demo, it's not the actual mirror that you will have in the telescope. That one is simplified, but it's already good enough for the purpose of this demonstration. Thank you very much for watching that until the end. If you want to have a look at the solution more in details, you can go on the website or maybe just ask me. I will be more than happy to do a specific demonstration for you. If you want also to try it for yourself, it's of course possible. Just ask me. And don't forget to follow me on LinkedIn for more information in the coming weeks and months. Thank you.